So now next point is about tangents and normals. So we know tangent is a line. In fact, it is a straight line. You can write is a straight line that touches the given curve. We know this. That touches the curve. Curve means what? Graph of a given function. So suppose this is a graph of a given function, and I have a one straight line like this. So we have a line like this that touches the curve at this point. So if I call this as x0 y0, so sometimes this is called the point of contact. That is known as what? That x0 y0 is called what? Point of contact. This is tangent or tangent line, you can call. This is the function y is equal to fx. Fine. So this is point of contact here, x0 y0. That's called point of here contact. Point of contact where the tangent touches the curve. This is the tangent line. Now to get the equation of a line, you have a point on the line, but you need the slope. So this is the first thing that we want to state now here. If you are given the curve means one function, y is equal to fx, and you have a point here as I've shown, which is called point of contact x0 comma y0, right? Then this is something which we are stating without proof. Slope of tangent at point of contact, that is at x0 comma y0, is given by dy by dx. You differentiate the function and get the derivative at that point x0 comma y0. Do you understand what we mean by this? You differentiate first, and then instead of x you put x0 and instead of y you put y0 after the differentiation. This is sometimes also written as f dash x. This is derivative, and then we write 0 here, x0. That means after differentiating, instead of x you put x0 and in place of y you put y0. So this is very important line here, important statement here. This is something which is the first thing Newton has observed before he developed the theory of calculus. Okay. But we are just stating without proof. Slope of the tangent in the next exercise, it's very important exercise. Slope of tangent, immediately you must have the dy by dx in your mind. But where the dy by dx? At a given point. Where you have drawn the tangent at x0 comma y0, this is called the point of contact. So at point of contact you must have derivative here. So what is the slope here? Slope is nothing but you can write f dash x0. I hope this notation is clear to you. This means you differentiate first, and then instead of x you put x0. You will realize further. Okay, so now very easily you can write the equation of the tangent. Equation of tangent, that is what we want to do everywhere in the next exercise. Equation of the tangent. Tangent, you know, it is a straight line. Passes through which point? x0 comma y0. So y minus y0, if you remember, slope into x minus x0. Very basic formula. But what is slope here? F dash x0. Right? So this is very, very important equation. Equation of the tangent. Y minus y0 equals to slope into x minus x0. Fine. This is equation of the tangent. Now one more thing we want to write, you know, equation of the normal here. Normal, the word itself says that's a line perpendicular to the tangent. Normal means what? Line perpendicular to the tangent, but not at any point, at the point of contact. Line perpendicular to the tangent at the point of contact. So if I draw one line like this here, then this represents the normal here. So this represents the normal. it's perpendicular to tangent at x0 comma y0 and through the point of contact. So equation of the normal now we want to write. What is the normal? Line perpendicular to the tangent at point of contact. Now what normal is? Again a straight line passing through x0 comma y0. So y minus y0 equals to slope into x minus x0. Can you suggest the slope of the normal? You need to recall the coordinate geometry. These two lines are perpendicular to each other. So which condition you are going to use? If two lines are perpendicular to each other, then what about the product of the slopes? If you remember, m1 into m2 equals to minus 1. m1 means the slope of the tangent. So what is m2? Slope of the normal. This will go down. So minus 1 upon f dash x0. Right? This is nothing but the equation of what? Equation of the normal. I hope there is nothing to remember. This is quite obvious. Tangent is a straight line passing through x0, y0 having slope as f dash x0 dy by dx. And what is the normal? That is a line perpendicular to tangent at a point of contact and whose slope is given by this, using this concept from the geometry, coordinate geometry, minus 1 upon f dash x0. Reciprocal with opposite sign. If slope of the tangent is 3, then this is minus 1 upon 3. Fine. So we have these two things here. Now we get into next exercise, which is just purely based on these two things, dy by dx, that is f dash x0, and this one. First question, 6.3. Find the slope of the tangent to this curve. So you are given the curve. Slope of the tangent means immediately what we need to recall? Derivative. At which place you are asked? At x equals to 4. That means this is x0. So we differentiate it. Let's differentiate it. So it will be 12x cube minus 4. So we write therefore slope of tangent, required slope of tangent equals to dy by dx, at which place you can just draw line and put here x equals to 4. This is x0 as per our theory. So just instead of x you put 4 here. So this is 4 cube minus 4. So this would be 64 into 12, which is 768 minus 4. So 764, right? You did nothing, simply differentiation. Slope of the tangent, immediately you must have derivative in your mind. Okay, next question, question number 2. Slope of the tangent to this curve, y equals to x minus 1 upon x minus 2, at which place? At x equals to 10. So you need to differentiate this. So dy by dx, how do we do it? I'll not do it by division rule, you know it, you do it. And therefore the required slope, that is the slope of the tangent, equals to, after the simplification here, you put the dy by dx in the expression instead of x10. So you will get the required, slope. Fine. Question number 3, third question here. What's the third question? Find the slope of the tangent, okay, to this curve. So you are given the curve here, y equals to x cube minus x plus 1. Okay. At the point whose x coordinate is 2. Now it's different language here. At the point means you have that x0, y0, right? And where this you are not given, this is 2. It's like previous 2 questions only. But here language is different. It's written in this language. At the point where x coordinate is 2, that means x is 2. So what you need to do? Get the dy by dx like previous 2 questions. It's very simple here, 3x squared minus 1. And therefore required slope of tangent obviously, which is dy by dx, at which place? At x equals to 2. This is given to you. So put 2 here, so 12 minus 1, so it would be here 11. Finished. Right? This much only. We have just used everywhere the slope of the tangent equals to dy by dx. What about next question? Find the slope of the tangent to this curve where again x coordinate equals to how much? 3. So in the fourth question, same procedure. You are given the function. Which function? X cube minus 3x plus 2. Where you are asked the slope of the tangent? X coordinate. That is, you can write just x equals to 3, like the previous question. So what's the slope of tangent? Get the dy by dx and put x equals to 3. Find dy by dx. You can do it, I'm sure now. This is not a big task for you. Get it and put x equals to 3. So we'll get the required value. Question number 5, fifth question. Okay. What is given to you? You are given curve there. Now you know such things. You are given parametric equation. Two expressions for x and y in terms of theta. Where you are asked for the slope of the tangent at theta equals to pi by 4. So what's the slope of the tangent? You know very well. Slope of the tangent is dy by dx at that place. Dy by dx at which place? At theta equals to pi by 4. Question is dy by dx. Now this is just from differentiation. So how do we get the dy by dx? You need to recall the parametric equations from the differentiation. So which is, you know, derivative of y with respect to theta upon derivative of x with respect to theta. You know very well all these things, right? Differentiation of y with respect to theta, chain rule. A 3 sine square and derivative of sine is cosine theta. Here a as it is, 3 will come in product. This is cos square and differentiation of cos is minus sine. Fine. This is simply, you know, differentiation. Derivative of y with respect to theta, derivative of x with respect to theta. These are parametric equations. You know it. Parametric equations. Just for your information. Okay. 3a will get cancelled, 1 cosine will get cancelled, 1 sine will get cancelled, minus sign is there. So what we'll get from this? We will get here, just a minute here. So therefore slope of normal you are asked in the question, which is equals to minus 1 upon minus tan theta, minus 1 upon f dash x. So it would be cot theta, but at theta equals to pi by 4. So put theta equals to pi by 4, cot pi by 4 is 1. So slope of the normal is 1. Slope of the tangent would be obviously minus 1. Now in the next question, question number 6 here. Find the slope of the normal to this at theta equals to pi by 2. Same question, you can do it. I'll not do it. Again you have parametric equations. So you can do it. And finally you put theta equals to how much? Pi by 2. Question number 7 here. Find the point at which the tangent to this curve is parallel to x-axis. Acha. Okay. You want point at which the tangent is parallel, tangent to this curve. Okay, so curve is this. Have you realized? Indirectly you are given the slope of the tangent. You want, now you don't want, this is good question now. You don't want the slope of the tangent. You want the point to, on this curve, this is for example curve. You need this point here, let me call x0, y0. Find this point in such a way that the tangent drawn here, this tangent must be parallel to x-axis. So if I draw a tangent here, this point, then it should be parallel to which axis? X-axis. What's the slope of the x-axis? 0. So indirectly slope of the tangent you are given. So from there you will get the x0 and y0. Okay, here tangent is parallel to x-axis. And therefore slope of the tangent equals to 0. Slope of tangent equals to 0. As slope of x-axis is 0, you know. Slope of x-axis equals to 0, you know. And two lines are parallel, then their slopes are equal. You have used this concept from geometry. right? This is parallel to x-axis. m1 equals to m2. Slope of the x-axis is always 0. Therefore, slope of the tangent is also 0. Okay. So now what we do? We put get the dy by dx. We get the dy by dx. Okay. So here dy by dx equals to 0. Keep inside, call that as 1. And what is dy by dx now? Get it? It is just 3x square minus 6x minus 9. So by 1 this is equals to 0. So you will get this point of contact. Dividing by 3, x square minus 2x minus 3 equals to 0. Factorize this. So x here, I need minus 3. So I'll write here minus 3 and I need minus 2. So plus 1 equals to 0. So minus 1 and 3. These are the values. Indirectly, there are 2 points. So this is like x0. You can call this as x0 if you want to call. You can keep x also, doesn't make any difference. Now how do we get the y0? The point is always on the curve. So second coordinate you can find by putting x equals to minus 1 here. So therefore y0 equals to, if x0 is minus 1, then y0 will be minus 1 the whole cube, 3 into minus 1 the whole square, minus 9 into minus 1 plus 7. Are you getting me what I did? Just I have placed x equals to minus 1 here. So I'll get the y, which is y0. So what we'll get here? Minus 1. This is minus 3. This plus 9 plus 7. So we'll get the 12 from this. This is 12. So the one point of contact x0, y0 you can write, which is minus 1, 12. Fine. This is 1. Now if here, I'll do here only, if x0 equals to 3, now that's the other point. You can call x also, remember, don't worry about it. Then y0 will be, what we'll do? We put here 3. So 3 cube minus 3 into 3 square minus 9 into 3 plus 7. So just we simplify here. What will get? 27 minus 27, again minus 27 plus 7. So this will get cancelled. Here you are left with just minus 20. So x0, y0 will be here 3 comma minus 20. So there are 2 points where tangent is parallel to x-axis. Minus 1 comma 12 and 3 comma. It may be like this. This is just for your information. Curve may be like this. For example, this is x-axis. We may have curve like this. Okay, so you can have tangent like this here. Tangent would be like this. Here, like this. This is tangent. One point is this, the other point is this. This tangent you can see just in a diagram is parallel to x-axis. So slope 0 here, slope 0. Fine? Understood what I'm trying to tell you? This one point, this is the other point. This is just rough diagram for your information. Question number 8. You are given this curve. Find a point on the curve. So you want that point of contact at which the tangent is parallel to the line segment joining these two. Achha. So in the previous question it was parallel to x-axis. Here it is parallel to line segment joining these two. We need somewhere dy by dx. I'll just keep the derivative. 2 into x minus 2 by chain rule into 1. So we have this. Okay. Now what is given here? Tangent is parallel to line segment joining these two. Joining these 2 points 2 comma 0 and 4 comma 0. What is the meaning of this? That means slope of the tangent, which is dy by dx, is equals to the slope of this line. How do you write the slope of this line? y2 minus y1, which is 4 minus 0 upon 4 minus 2, which is 2. So which concept you have used? m1 equals to m2. Have you realized what I did? You did the same thing in the previous question also. Their tangent was parallel to x-axis and you were knowing the slope of the x-axis 0. So there you had placed 0. Here you got the slope with these 2 points, y2 minus y1, 4 minus 0, 4 upon x2 minus x1. I've used this concept m1 equals to m2 because you are given parallel. What is dy by dx? You know, 2 into x minus 2 equals to 2. 2 will get cancelled, so x equals to 2. So indirectly this is, if you want, you can write point of contact as x0 like this. Suppose this is x0, y0 like this. Okay, slope you were given, you are finding this point. I hope the question is clear to you. You are finding this. This is the question here. Okay, now once you have x0, how do you get the y0? The point is always on the curve. So you can put just here x. I'm sorry, here this will get cancelled. So this is 1 and this will be 3. Just correct it. So x0 is 3 here. And therefore, how do I get the y0? Put x0 equals to 3 in the given function. So you can write y0 equals to x0, that is x, which is 3 minus 2 the whole square, which is just 1 square, which is 1. So the required point, you can write required point, that's the point of contact, which is x0, y0 equals to 3, 1. 3, 1. Okay, 9th question, you just read it, you see it's a copy of this same question. There you are given, see, slope of the tangent to this curve is there, tangent is parallel to this line, find the point. So again you are asked for x0, y0, point of contact. This is the question. You are given the curve. Now that tangent is parallel to that line. Your tangent, actually I should not do it, tangent is parallel to which line? Y equals to x minus 11. So slope of the tangent, which is dy by dx, you know always, that is equals to slope of this line. What's the slope of this line? It is in the y equals to mx plus c. So m is 1 here. So slope is 1. Right here, slope, can you recall? This is slope m equals to 1 here. And one more concept you have used here, m1 equals to m2. Now you put the value of dy by dx, get the x here, and this value of x you put into the function. So we'll get the y. You can call x0 and y0. So you will get the required point here, x0, y0. We did such 2 questions, so I'm sure you can do it here also. Okay. The next question number 10 now. See, the 10th question says that find equations of all the lines having slope minus 1. Okay, so slope you are given. So to get the equation of the line, what you need? You need point of contact, I mean 1 point. Here are tangents to this curve. In fact, you want all tangents, right? Here slope of the tangent you are given indirectly. Slope of tangents equals to, you look at minus 1. It is indirectly given. So it's like previous question only. You need to get the point of contact first. Slope of tangent you are given. But we know what is the slope of the tangent, that is dy by dx. Right, dy by dx you can find from this, minus 1 by x squared into 1 by chain rule, derivative of 1 upon x. You know what's the derivative of 1 upon x? Minus 1 by x squared. I've used this. You imagine this like x into by chain rule, derivative of this one is 1. But what are the slope of the tangent? That is minus 1. So you have minus 1 equals to minus 1 upon x minus 1 the whole square. So from this will be x minus 1 the whole square equals to how much? 1. So x minus 1 is equal to either 1 or x minus 1 is minus 1. So either x is 2 or x is what? 0. So there are 2 points. This is like x0. If x is 2, what is y? Put it in the function. 2 minus 1, it will be just what? 1. We are putting into the function. If x is 0, put here 0. What is y? That is nothing but put 0 there, so you will get minus 1, right? Where we got this from the function, just placing in the function. So this is 2 comma 1. Here one point is 2 comma 1. The other point is 0 comma minus 1. These are indirectly point of contacts. At these 2 points, tangents are having the slope minus 1 to the above function. Got it? So now we write the equation. How do we write the equation? You know, equation is y minus y1 y0 equals to slope. Slope you already given, minus 1 into x minus x0. This is point of contact, this is a slope. So we are using straightforward point slope form. So what we'll get from this? If you just simplify, this is x plus y, this is here plus 2. If I take on the other side here, minus 3 equals to 0. Over here, equation is, what's the equation? Equation is y minus y1. So here plus 1. Slope, you know it is minus 1 into x minus 0. So here you will get the x plus y plus 1 equals to 0. These are the tangents to the above curve with slope minus 1, and these are the point of contacts. So up to this is previous question. Point of contact. Here slope minus 1 you were given ready. I suppose 11th is the same question. I'll not do it. Find the equations of all the lines having slope 2. So slope 2 means instead of minus 1 here, slope equals to 2 given to you. Slope of tangents equals to 2. Ready. Okay. Minus 1 here 2. Flow of the solution is this only. Fine. And here curve is same, y equals to 1 by x squared. So what you need to do, just you get the dy by dx and compare dy by dx with which one? 2, right? And from this you will get the x, values of x, right? That is point of contact here, where you are going to put x in the function, so you'll get the y. So this is the point, this is the slope, and then use the point slope form. Use y minus y1 equals to slope into x minus that x0. So you'll get the required equation, that much. Just copy this. That's a flow of solution. So same copy of previous two. You are given the curve. Find equations of all the lines having slope 0, which are tangents. So indirectly these are the lines, but they are the tangents. So slope of tangents, all possible tangents, equals to 0 given to you. In previous two questions you were having 2 in the previous, and before that you had minus 1. Here you have 0. Flow of the solution, same as you did. Okay, now you know slope of tangent is dy by dx. Okay, so let me write here, but slope of tangent, you know it is equals to always dy by dx. Okay, so get the dy by dx. How do we get this? You imagine this is x. What's the derivative of 1 upon x? Minus 1 upon x squared. So x squared minus 2x plus 3 the whole square into, by chain rule, derivative of this. And what is that? It will be 2x minus 2. Derivative of 1 upon x is minus 1 upon x squared into derivative of this one, which is by chain rule 2x minus 2. Okay, so we are getting this minus 2x minus 2 upon x square minus 2x plus 3 the whole square. Now what we'll do? We are just going to put here. So therefore minus 2 into 2x minus 2 upon x square minus 2x plus 3 the whole square equals to 0. So you will get x from this. So 2x minus 2 equals to 0. So you will get x equals to 1 from this. This is, as I have mentioned number of times, this is x0 indirectly. How do we get the y? Put x equals to 1 in the given function. So here 1 square minus 2 into 1 plus 3. So it would be how much? Half here. And therefore the point x comma y, this is indirectly x0 y0, it is 1 comma 1 by 2. Now you have a point, you have a slope. So the equation of the tangent here, equation of tangent, will have just one tangent. Y minus y0, which is 1 by 2, equals to slope, which is x0 into x minus x1. So So this is 0. So therefore finally we are getting y 2y minus 1 equals to 0. This is required tangent here.